This is lesson 6.5 out of the Decimals and Fractions book. And if you're in Mrs. Walker's class, the notes today are going to be on page 58. Only one page for notes today. Lesson 6.5 is titled Volume with Fractional Dimensions. All right. Volume with fractional dimensions. Okay. So, warm up. Warm up today has 4 problems. Number 1. What is 1/3 times 3/5 times 10/21? 10/21. Number 2. What is 2 1/2 times 12/25 times 1 2/3? 2 1/2 times 12/25 times 1 2/3. Number 3 says find the area of a rectangle length equals 2/3 yard, width equals 3/4 yard. All right. And the final one, number 4, says find the area of a rectangle length equals 1 1/2 inch, width equals 1/2 inch. All right, those are your warm-up problems. Okay, our I can statement for this lesson is I can find the volume of rectangular prisms. And if you need to refresh your memory on what a prism is, look back in the notes on lesson 6.4. But it's going to have a top and a bottom base. All right. So it's another way of saying like a rectangular cube, only properly a cube is squared, not rectangular. All right. Dark green pencil signifies this is the end of my warm-up stage and we're going into the notes. Okay. I have one notes cut out, and it's going to go in the upper right, upper left, our kind of traditional, what we call the traditional position. And so, hold on a second while I get it glued on here, or you can just fast forward through this part. All right. Tiny tadpoles. There we go. And I'm going to put it right here in this position. And press it. Okay, so yellow highlighter highlights what we're talking about here. Volume of a rectangular prism. And my pink highlighter I'm going to use to highlight this formula. This formula we will use a lot. This is the formula for finding volume of anything, and you're probably already familiar with it. You should be. I know you've gone over it before, but what it stands for is volume equals length times width times height, and they spell it out here where L is length, W is width, and H is height. And you already know that, I know. But that's the formula for how to find volume. And in this case, we're talking about rectangular prisms. They show you some examples of different kinds of rectangular prisms down here. But this is what we'll be writing over and over and over again. It's one we will use a lot. Okay, so here we go. So our first instructions. Okay, so find the volume. Well, come on. Find the volume. All right, find the volume. Find the volume. I'm going to take my blue highlighter and just highlight that instruction. Put some color on our notes. Makes them a little more interesting. Easier for our eyes to land on certain things. All right. So I'm going to find the volume of a prism that has a length that equals 2 3/4 inches, a width that equals 3 1/3 inches, and a height that equals 1 4/5 inches. All right, those are the dimensions of my rectangular prism. And now I'm going to find the volume. And as always, when we're using formula, the first step is to write the formula. So V equals length times width times height. All right, and then we plug in the values that we've been given. So the length is 2 3/4. The width is 3 1/3. And the height is 1 4/5. Okay. Now we know we can't multiply mixed numbers until we turn them into improper fractions. So 2 3/4 equals 11/4 as an improper fraction. 3 1/3, 3 times 3 is 9, plus 1 is 10 over 3 times. 1 times 5 is 5, plus 4 is 9 over 5. We keep the denominator when we make these conversions. Now, the next step is to cross-simplify or cross-reduce, whichever you prefer. Now, when we have three numbers like this, we can cross-reduce as long as we're going diagonally. It could be from here to here, or from here to here, from here to here, from here to here. It doesn't matter whether we're jumping a fraction to do the reducing, as long as we're going diagonally. Now, the only thing I can see, let's see, I can see that 3 can go into itself once and 3 can go into 9 3 times. Good. These are two even numbers, so I know 2 is going to go into that 2 times, and 2 is going to go into 10 5 times. Now, we can double reduce, so to speak. Do you see now that we have 2 5s here? Yeah, whenever you have matching numbers, that becomes 1 and that becomes 1. So our multiplying is getting very easy. Can't do anything with 2 and 3. Can't do anything with 11 and anything diagonal down from it. So now I'm down to 11 times 1 times 3. So that's going to be 33. And then I've got 2 times 1 times 1, and that leaves me with 2. Okay, so then that equals 2 can go into 33 16 times with 1 left over. Scooch over that denominator, we keep it. And we are talking here about inches. Not squared. We've been used to saying square because we've been dealing with area and surface area a lot here lately. But now we're talking three-dimensional. Three-dimensional. We are multiplying 3 numbers. So it's cubed, which we signify with a little 3. Now again, you could write this as inches cubed, if you like. That's fine too. Or inches with the little 3 means cubed. Or you can even write 16 1/2 cubic inches. That would be another proper way to write that. Okay? I tend to just write whatever my measurement is with the little 3. It's quicker. That's what you'll see me use most of the time. So That is our final answer. So 16 1/2 inches cubed is the volume of this particular rectangular prism. All right, so let's look at another kind of problem here. Let's look at a word problem and how we would use it. So, the school recycling program wants to fill its recycling container with newspapers. The container is 5 1/3 feet long, 4 1/2 feet wide, and 4 3/8 feet high. Okay. What is the volume? What is the volume? All right, so I'm going to take my green highlighter and just highlight this first line, make it stand out. All right, here's what we're doing. Okay, so I don't want to go there. All right, so the school recycling program wants to fill its recycling container with newspapers. The container is 5 1/3 feet long, 4 1/2 feet wide, and 4 3/8 feet high. What is the volume? So to figure this out, the first step that we need to use is write the formula. So volume equals length times width times height. Then plug in the known values. The length is 5 1/3. The width is 4 1/2. The height is 4 3/8. We know we have to turn those into mixed numbers. So 3 times 5 is 15, plus 1 is 16 over 3 times 2 times 4 is 8, plus 1 is 9 over 2. 8 times 4 is 32, plus 3 is 35 over 8. Now I need to cross reduce. So I'll start with this 3 and turn it into a 1 because it can go into 9 3 times. I'll look also that 2 can go into itself once and into 16 8 times. Oh, but now I have a matching 8 and 8 here. Remember, I can skip a fraction if I want to, as long as I'm going diagonal. So 8 goes into itself once, and 8 goes into itself once. And now I just have, yep, there's nothing more I can do here. So I have only ones at the bottom, and 3 times 35 is 105. So my answer is 105 feet cubed. Remember, cubed with 3 there. 105 feet cubed is the volume of that recycling container. Now, here's another question I want you to ask yourself. If, and now I'm going to use my regular pencil. If they have a stack of papers with a volume of 126 feet cubed will it fit? Okay. Well, if the volume of the container is 105 feet cubed, and you have 126 feet cubed stack of papers, is it going to fit in there? No, that's more than what would fit in there. So the answer would be no. And on your paper, you might make a comparison to the numbers if it asks a question like this. I think with my pink highlighter, I'm just going to highlight the word if to show we got a because it'll ask you to do that. You'll have problems that'll ask you to find the volume, or it won't even ask you to find the volume. It'll tell you how much stuff you have, and then will it fit in a container with this much volume, and then vice versa as well. So that's the end of our notes for lesson 6.5. Let's take a look at our practice problems. Okay, 6.5 practice problems. Here we go. The first one says to use the formula V equals L times W times H, that's the formula for volume, to find the volume of a rectangle that has these dimensions. All right, we did that in our notes. That should be easy for you to do. Part B of this is okay, find the volume if these are the measurements, right? Now, problem number 2 is a cereal box has, a cereal box was 1 1/2 feet tall, 1 1/12 feet long, and 1/6 of a foot wide. How many cubic feet of cereal can the box hold? So just find the volume of this box is all it's saying, all right? Okay, so I will show you the top again here and pause. Show you the final problem and pause. Okay, so let's look at how we would solve these. First one is giving us these dimensions. The steps are always the same, no matter what the dimensions are. First, we're going to say volume equals length times width times height. Okay, and the length is 1 1/3 inches times the width of 3 inches times the height of 5 1/2. We need to turn these into improper fractions. So 3 times 1 is 3, plus 1 is 4. Keep the denominator of 3 times, put the 3 over 1, times 2 times 5 is 10, plus 1 is 11. Keep the denominator, put it over 2. Now we need to cross simplify. I see 2 matching numbers here of 3s, so those turn into 1s. I see this 2 goes into itself once and 2 goes into 4 2 times. There's nothing we can do with that 11. So that winds up being 2 times 11 is 22 over 1, which is 22. So the volume is 22 inches cubed. And we'll circle that. All right? Okay, part B of this. We're still trying to find volume of these rectangles. Volume equals length times width times height. The length is 6 2/3 feet. The width is 1 1/2 feet. And the height is 3 3/4 feet. Next step is to turn these into improper fractions. So we've got 20 over 3 times 3 over 2 times, 15 over 4. Now cross reduce. 2 can go into itself once and into 20 10 times. I see 2 matching 3s, so those become 1s. I see a 4 and a 10, those are even numbers, so I know 2 can go into 4 2 times, and 2 can go into 10 5 times. So I think that's as far as I can go now, which brings me down to 5 times 15 is 75 over 2. 75 over 2. And 2 can go into 75 37 times with 1 left over. Keep the denominator. So our answer is 37.5 feet cubed, or cubic feet. All right, circle that. Okay. All right, now we're down to the last one, our word problem here. So it says a cereal box was 1.5 feet tall, 1 feet long, and 1/6 of a foot wide. How many cubic feet of cereal can it hold? So we've got to find out what the volume is. V equals length times width times height. The length, again, we're multiplying, so order doesn't really matter. You know, if you want to call tall should be height, right? And long, and then we've got wide. So let's put them in the right place. But ultimately, it's not going to matter, right? Okay, so length is 1 1/12. The width is 1/6. And the height is 1 1/2. All right, let's turn these into improper fractions. I've got 13 over 12. 1/6 stays as it is. 3 over 2. All right, now cross reduce. 3 goes into itself 1 time and into 12 4 times. I can't do anything with the 2 and the 13 or the 6 and the 13. That 13 is prime, so that doesn't leave us with much. I don't think there's anything else we can do with that. So I've got 13 times 1 is 13. 4 times 6 is 24. Times 2 is 48. So I've got 13/48 feet cubed is how much cereal can go in there. Okay, so I'm gonna just circle that with this, but this is a word problem, requires a sentence. All right, so the box can hold 13/48 feet cubed, or cubic feet, of cereal. That's our final answer. Okay, so that's the end of our practice problems. Let's take a look at the worksheet for lesson 6.5. All right, the top part is much like the first problem in our practice problems. You're going to need an extra piece of paper. There isn't enough room here to write the formula and work it all out, most likely, unless you're writing really tiny. And you do need to show all the steps. So you're going to have to find out what the volume is with all of these different dimensions. Here they're talking about a box that measures this, so figure out the volume, and then they want to know, well, if a paper company wanted to fill the box with this much paper, would it fit? Very similar to what we talked about when we were making the notes. Very similar problem here again. Now, down here, you need to get a ruler and measure the lengths and widths of these prisms. And it says to the nearest eighth of an inch. And they'll be real easy measurements. They're not going to be tricky. And find the volume of the prisms. So it's the same as what you did up top, only now you have to find some of your own measurements. Okay? So pretty straightforward on the worksheet. All right. Last is your exit ticket. If you are interested in doing a little more practice, you may use this to do it. Your teacher may use it in other ways. I don't give you the answer to these. Okay, so that's the end of lesson 6.5. Remember, the only way to learn math is to do math, and mistakes are proof that you are learning.